Yeah, very good morning to all. So today let us discuss about energy storage using electrochemical process. We call it as electrochemical storage. We all know power can be generated and transferred. We cannot hold it. So if you want to hold it, you want to store it in batteries. So battery, inside the battery we have this electrochemical process involved. So moving into the slides. Electrochemical storage refers to the storage of electrical energy in chemical form. Okay, so it's nothing but a battery which can be later converted back into electrical energy when needed. This is a fundamental principle behind batteries, supercapacitors and other electrochemical energy storage device. I will tell you what is the advancement done or what is the current status. So what we have done is India has 3 navy ships, submarines, and inside that submarines we have kept batteries, and that batteries is being charged from the land, which means whenever you have surplus power generation or whenever energy consumption is less. For an example, when you take a day, morning we will all be at home, so we will consume more power, and we all will leave to office, school, colleges during time between 10 to evening 4 to 5. The usage will be very less. So at that time the power supplied to the domestic areas, housing areas where is not being used. So what we can do is at that time these powers can be used to charge a battery, and whenever required by evening your load will increase. Okay, industrial loads will be always there round the clock. I am talking about domestic load. So what happens is during evening industrial load plus domestic load will be there. So at that time what I can do is I can discharge from the battery. Okay, so in that case army, I have told, no, in navy they are having 3 submarines. So under any circumstances, if any war or anything is happening, even if our enemy countries try to destroy our power plants, there is no issue. Power from this 3 submarines which is kept under ocean will try to supply entire southern region of India. So these materials stores and release the electrical energy through electrochemical reaction, making them crucial for applications such as, we say, electric vehicles. Nowadays our future is we are going to move towards electric vehicle, since our petrol diesel is getting depleted. So in that case we need this electrochemical storage method, making them crucial for applications such as electric vehicle, renewable energy integration. That renewable energy integration is what I have told. See, solar panels will be able to generate from morning 10 to 3. At that time the industrial loads will be less. So due to this domestic load less, we will try to store it in a battery. Then during the evening hours we will again get it back. So under electrochemical energy storage system we have 2 main type, which is called battery energy storage system, then flow battery energy storage system. There is a small difference between these two. I will tell what is energy storage system and the flow battery energy storage system. Principle behind is same, only small variation will be there. Okay, under this battery energy storage system we have lithium acid, nickel cadmium. Now we have sodium sulfur batteries and sodium ion batteries. Okay, and one more is lead air battery and solid state battery. So there are totally 1 2 3 4 5 different types of electrochemical storage under battery energy storage system. Okay, lead acid we all know, it was the pioneer in the field of batteries. So from the earlier days we started with only lead acid batteries. Since it has a liquid in it, it is slightly dangerous when you keep it on moving objects. So we have moved to lithium ion. Okay, so in lithium ion we will see what is there in positive and what is there in negative, and which is being used as an electrolyte. So in a battery only 3 parts are there: one electrode, one anode, and then third one is what type of electrolyte you are going to use. So when under lithium ion, when you see cathode is made up of lithium cobalt, lithium iron phosphate, lithium nickel manganese cobalt oxide, lithium nickel cobalt oxide. You can have a doubt why you want to have such so many types of cathodes. So depending upon that, your safety, usage, long life, more number of recycle capability will increase. And when you see in Tesla, they use lithium nickel cobalt aluminum oxide as an cathode, which is very high energy density, which means when you take same battery of size, let us assume 1 cubic square meter or 1 cubic centimeter or 1 cubic area, the same amount of volume occupied by lithium nickel cobalt aluminum oxide will be able to deliver more power. That is mean as high energy density. Next comes what are all types of anode material. Usually in batteries, a common person is graphite. Wherever you see anode, usually anode will be graphite. And there are some more which is nothing but silicon based anodes, then lithium metals. There are some advanced research which has led into these fellows, but initially we had only graphite. Then we move on to electrolyte material. This is the third. In a battery you should have a cathode, you should have an anode and an electrolyte material. So in case of lithium ion, liquid electrolytes like lithium salt, LiPF6 is an organic solvent which is being used, or you can go for solid state electrode like sulfide based or ceramic or polymers electrolyte for improved safety. Safety is nothing but you should not keep any liquid inside the battery. There is a chance for the liquid to come out, so we go for solid. So this is the inside of your lithium ion. You can see when you give an external supply, the charges in the electrolyte will be saved, and when you want to take out, the charge from the electrolyte is being brought out. So this is how it is working. Then comes sodium ion batteries. In sodium ion batteries, the cathode material is nothing but sodium based analogy of lithium ion like Na3V2, and anode material is hard carbon. So carbon is again nothing but an graphite. Okay, electrolyte is sodium salt. By the name itself it is very clear, you have to use sodium salt. Sodium salt is a base. Wherever when you say electrolyte should be of base type. Okay, so here we have taken sodium salt as an organic solvent or a solid state electrolyte. And the sodium based batteries are cost effective alternate to lithium ion, whereas lithium is a material we have to dig from under the ocean, whereas sodium is available on plenty on the surface. Even when you just take the sea water, by the process of evaporation you can get sodium as a product. Okay, so it is cost effective alternative to lithium. This is lead acid. We all know the name lead acid is being given because we are using H2SO4. H2SO4 is nothing but a sulfuric acid. Sulfuric acid is taken as an electrolyte. That is why we call it as lead acid. Okay, so lead is being taken as a positive electrode. Then one more sponge lead, which is nothing but we are going to take about the negative, and the electrolyte we all know you will use sulfuric acid, and this is the reaction which will be take place. So this excess electron has been liberated. This electron we will try to bring it outside when you are using the battery in the discharge mode. So this is how the copper sheets will be arranged in lead acid battery, and in between these sheets we will try to pour the acid, concentrated acids, then followed by we will add a distilled water. It should be a distilled water. You should not have any dissolved salts in it. Okay, then move on to solid state batteries. These are the research areas we are going on where you don't have any liquid inside the battery, so that is what we call it as solid state. So when you try to bring a battery like this, then the placement of the battery in the electrical vehicle problem will be solved. You can even keep upside down, you can keep it in a vertical position or in an horizontal position, so that space occupied will become reduced. See, when you want to keep the battery only up on the position, then you require more space. If you put it on lay down basis, the space will get reduced. That is why we go for solid state. So here material used is solid electrode, Then advantage, improved safety, high energy storage. In future EV electrical vehicle, we will go only with solid state batteries. Now we move on to the next type of thing which I have told is flow battery energy storage system. So please listen, only small difference, which is nothing but you will have an electrode, you will have an anode and cathode, but in between electrolyte is usually in normal batteries is kept at a one particular quantity. But what happens when you increase the volume of the electrode, automatically the power produced will increase. So what we have done is we have kept it like a bottle. On both sides we have electrode anode. Now I am going to pump my electrolyte from outside. The amount of electrolyte I am pumping will be directly proportional to the power produced. When you pump more electrolyte inside it, power produced will be more. So this is like increasing the performance. So you can vary the power generation. Normal batteries, if you say 12 volt, it is a 12 volt with a particular amps. If I want to increase the ampere rating, you have to go for an additional battery. Whereas in case of this, if you increase the inlet flow, automatically your amps will increase. So that you can see here, this is called electrolyte tanks. So from electrolyte tanks, I will try to pump electrolyte into the battery structure. Thereby you will have electrodes and cathodes. When more amount of electrolyte is there, more amount of current will be coming out. See, voltage is constant, only current will increase. And since power is equal to V into I, if I increases, automatically the product between V and I will increase, and thereby power will increase. So working, electrolyte stored in a tank. Flow battery use liquid electrode stored in a separate external tank. Pumped through the cell tank, that is step 2. So electrolytes are pumped through the reaction cell. So third one is reversible reaction. The reaction will reversible, allowing recharge when electric power source is applied. Key feature, it has more stability, more long life, deep discharge availability, enhanced safety. Then there are some challenges in electrochemical storage, which is nothing but whatever combination you try to put in a battery like electrolyte or electrode anode, the thing is you should have an high energy density and power density. Then you should have a cycle life is nothing but the how much time you can charge and discharge. That should be more. Safety concern, there should not be any thermal runaway problem. Thermal runaway is nothing but when you use it, it should not increase the temperature inside the battery. Thereby if the temperature increase, there is a chance for blasts. Okay, then suitability and raw material. So see, under any research in laboratory, if you are able to generate power, that is not the thing. That should be brought to the real world, which means the raw material which you are using should be abundantly available on net source. If it is a rare material, then there is no use at all, even if it is high density, high life cycle. But if we are unable to produce in large amount, it is waste. So that is we called as sustainability and raw material. Next come cost and salability. Cost should be within the limit, and if you want to multiply or add, you have to go for scalability. Then next one is environmental impact. So mining impact on lithium, cobalt and nickel extraction need green battery chemistry and improved recycling. In normal batteries, the issue is how we are going to dispose this lithium, how we are going to dispose the nickel. So we have to try to make a battery such that after utilization, if you are going to dump, and when you dump, that should not damage the environment. So that is what we say is as environmental impact. Then fast charging and efficiency. Initial days with lead acid batteries, it takes around 3 to 4 hours or 5 hours. But when you use it in your electric vehicle, once the battery get drained, if you are running in an highway, you will not have a time to sit and go for 5 hours or 6 hours charging. So you should have a fast charging method such that just by an half an hour or a 45 minutes, where I am going to take my lunch on highway, so I can put it in charge and I can have a lunch and come back and take the vehicle. So within that time, if the battery is able to get recharged, then that is what I require. So that is why we call it as in research is going on how to do fast charging with more efficiency. When you go for fast charging, the reverse thing should not occur. When you are able to charge fast, efficiency should not come down. Efficiency also should be high. Simultaneously, I will ask to charge fastly. So thank you. This is with respect to how we are going to do it. Thank you for listening. If you have any doubts or suggestions, you can kindly give a comment on my YouTube channel. If you have not subscribed to my channel, kindly subscribe. Thank you.